Hi everyone, welcome to Developing Progressive Apps Responsive Design Part 2. Today we are looking at media queries. I'm Jasper. Before we dive in, there's a bit of setup which you need to do. If you're following from the last lab, which is part 1, there's no need for you to do this setup. We are already ready to go. But if you are just interested in this part, you are free to pause this video and follow the steps outlined in this setup. Let's now have a quick look on our starter files. The first one is our HTML, which contains an outer div with a class of container and 3 children, which are all divs with a class of COL. We inserted this meta viewport tag in the previous lab. Now for the main CSS, there's nothing much here. We have just targeted that outer container and the columns, setting the width of the columns to 27% so that they fit in one row. Now opening our browser at localhost 8080, you see that at large device width, things seem to be okay. But look what happens is I resize. You see our columns, instead of rearranging themselves, they are just being spaced together. And this is not what we want. So we are going to rectify this using media queries. Let's now have a quick look on media queries. These are just simple filters that can be applied to CSS styles based on media type. And when you say media type, you are referring to, is it for print, is it for viewing on the screen, or is it for speech synthesizers? And that O there is the default, which matches O, that is print, screen, and speech. They also apply CSS styles based on media features, and these media features, they are specific characteristics of the user agent. That is things like width, height, orientation, color, etc. And the media features must be enclosed in parentheses. We shall see when we do the demo. And many of these features, they are range features. That is, they can be prefixed with minimum or min or max, signifying the minimum value or the maximum value. You must take note that when designing, we use what we call mobile first. That means to say we design first for the smallest devices and continue to enhance our application as screen estate continue to increase. So when you say min, for example, min width, we are saying the minimum width from which the selected styles should be applied. And we say maximum, we are saying from the minimum, which is our mobile or the smallest which we are designing for, up to that maximum, the media query will be true. Right, media queries can also use logical operators. The AND operator, this is used to combine multiple media features into a single query, and it returns true only if all those features are true. Can also be used to join media types and media features. The NOT operator it negates a media query. And when you use a not operator, you remember we said the media type is optional. But when you use the not operator, and the only operator which you see in a moment, the media type must be supplied. It ceases to be optional. The only operator is used to apply a style only if an entire query matches. And this is intended for older browsers and has no effect on modern browsers. Like I mentioned, when you use this one also, the media type must be supplied. Then the comma is similar to the or operator that we use in other programming languages, but here we use a comma instead. And the query evaluates to true if any of the media query evaluates to true. Right, enough of theories. Let's now go into the main CSS, our style sheet, and see the media query in action. So I will insert this media query and explain what's happening. You see here, we use this at sign, that's at media. Then the screen here is the media type that we talked about. And the end is the operator. And the max width is the media feature. And we are saying from the minimum, remember we say we design mobile first style. So we are looking from the smallest up to the maximum width of 48 rems. We want our width to be 95%. The default was 27%, which makes them to fit in one row. But here I say now the width is 95%, so that each column takes the whole container width. I will speak more of why using 48 rems here instead of the traditional pixels. And also another way of writing this same media query, getting the same results. Because here it's not very usable, because we are constraining it to be in this main CSS. But what if we want this to apply to our other HTML? I cannot now come here and select this one. So there's another way which I'll show again towards the end of this presentation. So now let's go to our local host and see the results. Right, things looks familiar here. But let's see what happens when I resize. Wow. You know, see what's happening? Our 3 columns, a small device width, which is 48 rems, and below, the columns are arranged now in a single column rather than 3. If you check, you see BS here, that was another column, but they are now arranged in a single column, and that's what we want. Right, as mentioned earlier, using the at rule, that is at media, may not be suitable for other use cases. Say maybe you want to include this media query to multiple files. You may need maybe to make it be in a standalone file rather than being tied to main CSS. Behind the scenes, I've created a new CSS file and I named it smallscreen.css. It is empty at the moment. So let's comment out this media query and copy this one and then paste it in our smallscreen.css and move on to index.html, and we want to use this link tag, as we did here, to link to our small screen.css. So I insert this one. It's the same structure with this link which you are familiar with. But here, the link also takes a media attribute. And you see now the screen and max width was 48 rems is the same as this one, this media query, this one actually, right? But here we are using the link and the attribute, the media attribute, to point to our small screen style sheet. So if maybe you want to link it from different files, you just use this same link and it will link to that same style sheet. So let's move on to our local host and see if things are still behaving the same. So we are here. You see, it's just still behaving the same way. Now let's have a brief look at pixels, rems, and rems. I think before we move on, it is good to appreciate that the browser, every unit is converted to pixels. So whether we use rems, but at the end, the browser will convert those into pixels. Right? What is a pixel? Pixels, they are absolute. That is to say, they will have the same CSS pixel value on any device. They are not responsive. They are set in stone. I may equate them maybe to being hard-coded if you are talking of other programming languages. They are not affected by inheritance. Now, we move on to what we call font relative lengths. There are about 4 of them, but we only look at rems and rems because these are commonly used. First, we have a look at rems. Here we are looking at what they are in the context of an element. That is, if they are used in an element. So 1m is equal to computed value of the font size property of the element on which it is used. You see, and there is a bit of misconception. You hear some definitions saying computed value of font size property of the parent element. And this is not necessarily so, but it sometimes appears that way because of inheritance. Otherwise, it is relative to the font property of the element on which it is being used. And ems are very much affected by inheritance. That is, when you are speaking in the context of them being used in elements. Now, the rem, looking again in the context, if it is being used in the context of an element, 1 rem is equal to computed value of the font size property of the root element. And usually this is the HTML element. And the HTML element usually gets its font size from the browser. Generally, this is not affected by inheritance. Note here I say generally, not affected. Because sometimes there is a bit of hint where it is affected by inheritance. But we'll not look into that now. But here we are looking at media queries. And you see the definition from W3C. It says, when used outside the context of an element, such as in media queries, these units refer to the computed font metrics corresponding to the initial values of the font property. So, in a way, they are saying, when we use them in media queries, M and rem, they refer to the same thing. The initial values of the font property, they usually come from the user agent. which is the browser in our case. Let me quantize you a bit that when you look in most tutorials, you see that they say you must use rems because they are not predictable because of inheritance. Those definitions, they are correct if we look in the context of using them in an element. But in media queries, as you can see here, the ems and the rems, they refer to the same thing, which means they'll produce the same result. We'll do a bit of a demo just for us to appreciate that. Before I demonstrate on why we should use rems and ems in our media queries, media feature portion, let me demonstrate how inheritance works so that you appreciate when we'll be doing our demos. So I'm here in localhost 880 and with the DevTools open, and I've selected the HTML element, and I'm interested in the computed font size, which is 16 pixels. This HTML is getting this from the browser. If I come to settings, we go to font size and change it to large. You see now the font size, HTML is still selected, the font size is now 20. So you see it is picking its font size from the browser. Also of note, if I select the body, you see it's also 20. It's inheriting from HTML. The same if I select this outer container, it's 20, and it's inheriting from body, from its parent. Again, if I select this inner column, it's still 20, and it's inheriting from the parent, which is the container. If I say, let's change maybe this one, the HTML, let's change the font size to 12 pixels. Okay. Again, if you go to body, you want to see the computed here, you see it has changed to 12, because it's inheriting from the HTML, which we have set to font size of 12 pixels. So that's how inheritance works. Let us now see why we are better off using rems or ems in our media queries instead of pixels. One of the greatest rule of thumb of setting our breakpoints is that let the content itself decide where you should put a breakpoint. Never design your breakpoints according to device brands, types, or sizes, but let the content itself decide. Let us go to the browser, right? If I resize, nothing has changed. And I think of note, I check here that the breakpoints is happening at 768 pixels here. That's where the breakpoint is. This is 768 because of 48 rems, and here the default font size is 16. So 16 times 48, you get 768. But I want you to take note when I change, say to very large, just to make it very clear. We'll change the font size to very large. Okay, initially the breakpoint was at 768 pixels, but now we are over 1,000, and because we are using rems, the breakpoint changed automatically, taking into account that we are now using a larger font, and it adjusted accordingly. This is what we call designing a breakpoint according to content. Let the content decide. it was not fixed at 768, but it changed because we are also using larger font. Let's change again. Say, let's go to very small just to make it very apparent. Okay. See, we went down to about 430 something, because also the font is smaller, so the breakpoint adjusted itself because we are using rems. So we are satisfying the principle that content must decide the breakpoint. Just to make it apparent, let us change here from 48 rems to 48 EMs. And go back to, and let's hard reload this one and empty cache, so that you know we are using that new setting. You see, it's acting just the same. Like the W3C said, that when you use ems and rems in a media query, they're pointing to the same thing. So there's no difference here in using rems or ems. Right, let's now have a quick look at how using pixels fares. Here I've hard-coded the max width to 768 pixels. And if you go to the browser, see that initially it behaves as if nothing is amiss, because we've used the same value, 768, which is equals to 48 rems at default font size of 16 pixels. So it is similar here, but let's now change font size of our browser to very large. Go back. Okay. You see again that it's not changing. The breakpoint is still at 768. It's not taking advantage of the large font which we are now using. And let's go back again. Let's change the font size to very small. Again, the breakpoint is still the same. And you see that our text is not looking good. This is too long. So when you use pixels, it's like you are designing for a particular device size and not designing it according to the content. Right, before we go, here are some points that you should take home. Create breakpoints based on content and never on specific devices, products or brands. Design for the smallest mobile device first, then progressively enhance the experience as more screen real estate becomes available. Keep lines of text to a maximum of around 70 or 80 characters. That is about 8 to 10 words in English. Next up, we'll see how we can get a similar outcome, but using the flexbox instead. See you in part 3. Thank you.